Mechanical engineering relative to power generation. Mechanical engineering is typically divided into the following sections: engineering, mechanics, machine design, manufacturing, thermal, mechatronics, aerospace, biomechanical fluids, environmental, automotive, naval, architecture and marine, materials science, engineering. Engineering mechanics. This section focuses on the fundamental principles of mechanics, such as statics, dynamics, and thermodynamics. These principles are used to design and analyze mechanical systems. Machine design. This section focuses on the design of machines and machine components, such as engines, gears, and bearings. Machine designers consider factors such as strength, durability, and efficiency when designing machines. Thermal engineering. This section focuses on the generation, transfer, and use of heat. Thermal engineers design and analyze systems such as power plants, heating and cooling systems, and refrigeration systems. Fluids engineering. This section focuses on the behavior of fluids, such as gases and liquids. Fluids engineers design and analyze systems such as pumps, turbines, and fluid flow systems. Mechatronics. This section is a hybrid of mechanical engineering and electronics engineering. Mechatronics engineers design and develop systems that combine mechanical and electronic components. Aerospace engineering. This section focuses on the design, construction, and operation of aircraft and spacecraft. Automotive engineering. This section focuses on the design, construction, and operation of automobiles. Biomechanical engineering. This section focuses on the application of engineering principles to the human body and other biological systems. Environmental engineering. This section focuses on the design and development of technologies to protect and improve the environment. Materials science and engineering. This section focuses on the development and use of materials in engineering applications. Naval architecture and marine engineering. This section focuses on the design, construction, and operation of ships and other marine vessels. Electrical engineering relative to power generation. Electrical engineering is a broad field that encompasses the design, construction, operation, and electrical engineers' use their knowledge of physics, mathematics, and engineering principles to design and develop systems that can generate, transmit, distribute, and use electrical energy. Electrical engineering is typically divided into the following sections: power engineering, electronics engineering, control engineering, signal engineering, telecommunication, computer engineering, electric-magnetic, microelectronics, photonics, instrumentation and control, power, renewable energy, VLSI design. Power engineering. This section focuses on the generation, transmission, distribution, and utilization of electrical power. Power engineers design and operate power plants, transmission lines, distribution systems, and substations. Electronics engineering. This section focuses on the design and development of electronic devices and circuits. Electronics engineers design and develop products such as computers, smartphones, and medical devices. Control engineering. This section focuses on the design and development of systems that control the behavior of other systems. Control engineers design and develop systems to control everything from cars and airplanes to industrial processes and robotic systems. Signal processing. This section focuses on the processing of signals, such as audio and video signals. Signal processing engineers design and develop algorithms and systems to filter, compress, and enhance signals. Telecommunications engineering. This section focuses on the design and development of telecommunications systems, such as telephone networks and cellular networks. Telecommunications engineers design and operate systems that transmit voice, data, and video signals over long distances. Electromagnetics engineering. This section focuses on the study and application of electromagnetic fields. Electromagnetics engineers design and develop devices such as antennas, radars, and microwave ovens. Microelectronics engineering. This section focuses on the design and development of microelectronic devices and circuits. Microelectronics engineers design and develop semiconductors, integrated circuits, and other microelectronic components. Instrumentation and control engineering. This section focuses on the design and development of instrumentation and control systems for industrial processes and robotic systems. Renewable energy engineering. This section focuses on the design and development of renewable energy systems, such as solar and wind power systems. VLSI design engineering. This section focuses on the design and development of very large-scale integration VLSI circuits, such as integrated circuits used in computers and smartphones. Combustion engines.
What is engine? Engine simply as a machine that converts heat energy to mechanical energy. The engine does this through either internal or external combustion.
What is combustion? Combustion is act of burning. What is an internal combustion? In internal engines, the burning of fuel takes place inside the engine, that is, burning takes place within the same cylinder that produces energy to turn the crankshaft.
Internal combustion engine.
What is the external combustion engines? In external combustion engine, such as a steam engines, the burning of fuel takes place outside the engine.
How power developed by these engines. The power of internal combustion comes from the burning of a mixture of fuel and air in a small, enclosed space. When this mixture burns, it expands. The push or pressure created then moves the piston, thereby cranking the engine. This movement is sent back to the shaft to drive alternator. The power of external combustion engines come from outside source such as boiler to produce steam, which created the push or pressure to move piston and do same job like internal engines.
The one-cylinder engine consists of 4 basic parts: cylinder, piston, connecting rod, and crankshaft.
In brief, this up and down movement produced by the burning of fuel in the cylinder results in the production of power from the engine, and this up and down movement called reciprocating movement. This movement consists of intake stroke, the compression stroke, the power stroke, and exhaust stroke.
Describe intake stroke. The intake stroke in a reciprocating engine involves the downward movement of the piston within the cylinder. During this phase, the intake valve opens, creates a vacuum, allowing the air-fuel mixture to be drawn into the combustion chamber through open intake valve.
Describe compression stroke. After the intake stroke, the piston begins to move down. Both intake and exhaust valves are closed during this stroke. The air-fuel mixture is compressed, increasing its pressure and temperature in preparation for combustion.
Describe briefly power stroke. When the piston reaches at the end of the compression stroke, the spark plug ignites the compressed air-fuel mixture. Rapid combustion forces the piston down. This downward movement creates mechanical energy, turning the engines, crankshaft, and producing power.
Describe briefly exhaust stroke. After the power stroke, the piston moves back up from bottom, the exhaust valve opens, and the piston pushes the burned gases out of the cylinder. This prepares the engine for the next intake stroke by clearing the combustion chamber of exhaust gases.
Upper portion of cylinder chamber is called TDC, top dead center, and bottom part is called BDC, bottom dead center.
To be continued.